All right, so this week we're going to start our practice or review with transformations. And one of the first things that we have to do is review all of our parent functions. There's one parent function that you haven't learned yet, and that's the one I'm going to cover in this page of notes. This page of notes is on page 52, and this video should not take that long. Remember to write your name and class period at the top of your notes. All right, so as you're looking at page 52, you'll notice that there are two different ways to represent this function called the floor and ceiling function. So one of the representatives is the floor function, and that's the one we're going to talk about first. Now, both of these are step functions. They're sort of a piecewise function, but they look like stair steps. You go from one step to the next. And we'll actually talk about class when these functions are applicable in the real world. When would we use this model of function in the real world? And so this one is used quite often actually. But first, let's look at some annotations and what the graph represents. All right, so the first one we're going to look at is the floor function. So if you'll notice that in this floor function, you have what looks like an absolute value, but it's not an absolute value. You've got a little line here at the bottom right here like this. What this means is that you're going to graph a piecewise function that's a step function. And in this case, we're going to graph a floor function. And what does that mean? All right, so what this means is if I have this value, 4.9, inside my bracket, I'm going to round down to the next lowest integer. So remember, floor is low. So you're going to take this value, this 4.9, and you're going to round down. So we round down and we get 4. Same thing with the negative number. When I round this number down, I get -5. So let's look at a number line. Okay, so if my value for my floor function is at 4.9, I'm going to round down to 4. And if my function is at -4.9, I'm going to round down to -5. So you see on the number line how this works. So if it's a floor function, round down to the next integer. All right, so let's take a quick look at the graph. If you notice that on this piecewise function, each one of these is a separate piece. And when we get to this point right here, we step up to the next level. When we get here, we step up to the next level. This keeps it a function because remember, we can't have two values of y for this one value of x. So one of these points has to be open circle. So since this is a floor function, all of the lesser ends are going to be closed circles, and the higher ends are going to be opened. So lower end closed, higher end open, lower end closed, higher end open. This represents a floor function. Also, we have some other annotations for floor function besides the one I've shown you right here. This one right here. We could also use these like double brackets that represent floor function, or we could use also these bolded brackets. So if they're bolded brackets, or if they're these double line brackets where they curve in, or we can use this. This is the one that we use the most often is this one. But we could use this one, or we could use the bold one, but most of the time we're going to use this one. And I believe on the test, this is the one that is used. So it's easiest to read because the bottom of the graph right here is the part that's extended right here on the bottom. So it's easy to remember that that's a floor function because it's the bottom that's indented. This is not the same as absolute value. Please don't get that confused. This is not the absolute value. This is a floor function. That means I'm going to I'm going to go down to the next lowest integer. Okay, so the same concept works for the ceiling function, except as you can see, for the ceiling function, we have the top of this these lines that are extended inward. So this means ceiling. So what this means is we're going to take this number 4.9 and we're going to round up to the next highest integer. All right, so we're taking our 4.9 and we are rounding up to 5. So here's my 4.9, I'm rounding up. And then my negative 4.9, I'm rounding up. So if you have a ceiling function, you round up. The brackets for this are different. If you notice that in the explanation on your notes, the brackets for ceiling functions are a little bit different. We have, instead of them closing in on the bottom, they're closing in on the top. If you notice right here, they close inward at the top. That's a ceiling function. Also, the brackets are different. For ceiling functions, the brackets open outward like this. Notice how the brackets open outward, either this double line bracket or the bolded bracket. They open outward. That means that it's going to be a ceiling function. Please, please, please don't get this confused with absolute value. It is not the same thing. So that's all there is for floor and ceiling. The next thing we're going to take a look at is transformations. And I just want to do a quick review of transformations with you before we actually do that activity this week in class. That'll be on a separate video.